Okay, so this is going to be the rest of the questions that we did not get to. So here we have a piecewise defined function, and again, you just want to graph this first piece, 5x minus 4 for x less than or equal to 1, closed circle, which will be this line, and then y equals 2, which is a straight line, y equals 2 for x greater than 1. So open circle here. All right. This one we did in class. Okay, so actually we actually got to this one as well. So we used the calculator for this one. We've got the possible rational zeros here. We've done that one. And we did this one. And we finished this one. Okay, so let's take a look at 16. So a couple things you want to know. Be able to determine the minimal degree, the power function, and the real zeros of odd multiplicity, real zeros of even multiplicity, and max number of turning points. So one thing to notice here is the max number of turning points is the degree minus 1, and we can count those. So we've got a turning point here, 1, 2, 3, 4. So the maximum number of turning points is 4, and so that means the minimum degree must be 5. The degree cannot be 4, right? Because if the degree was 4, and you have 4 minus 1, the maximum would be 3 turning points. There's more than that. So it's always one more than the number of turning points. Okay, so now we just identify the zeros here. So we've got a 0 at 1, minus 1, minus 2, minus 3, minus 4, minus 5, minus 2, 2, and this is a little more than 4, maybe 4.3 or something like that. That's what I estimated it as. Okay, so we'll create this chart where we list the zeros out, the multiplicity. Okay, so if it crosses, so here the graph crosses at minus 5, that means odd multiplicity. If it touches the graph, that means even multiplicity. So here it touches, and this is going to be even multiplicity. Here it crosses, that's odd. Here it crosses, that's odd. Okay, so we've got this chart, and that will tell you where it crosses and touches. And then the end behavior, if you look at the behavior of an x cubed function, since this is minimum degree is odd degree, then it's going to be x cubed, x fifth, x seventh. So we'll just look at x cubed. And this is the behavior of x cubed. When x is positive, y is positive. When x is negative, y is negative. So that's the end behavior here. And then I just graphed this to kind of see if it matches similar to what we have, and it does. Okay. So here we have asymptotes. So vertical asymptote and horizontal asymptote. Okay. So here we have the function r. And looks like, let's get rid of 7x minus 6, x plus 2, that's supposed to be x plus 9. X plus 9. And then we'll just set, to get the vertical asymptote, we just take this and set it equal to 0. So x plus 9 equals 0, and x equals minus 9. This is a vertical asymptote. Horizontal asymptote, if the powers are the same, which they are, degree 1, degree 1, it's just going to be the coefficients. So 7 divided by 1 is 7. That's the horizontal asymptote. Now this one we're going to factor. So here we always want to factor. So difference of squares is the numerator, and then the denominator factors x minus 3, x minus 2. and then we cancel the x minus 2 factors, x plus 2 over x plus 3. So again, a vertical asymptote, just take the denominator, set it equal to 0, and solve. And then the horizontal is going to be the coefficients. So the coefficient here is 1, coefficient here is 1. So we get 1 over 1 gives me 1. Okay, number 18, we want to be able to know when a function is 1 to 1, and it's 1 to 1 when it passes the horizontal line test. So this is 1 to 1. This is not 1 to 1 because it intersects here and here. So be sure you know vertical and horizontal line test. You can refer to these questions here, page 268. Now, if it is 1 to 1, which it will be, find the inverse. So to find the inverse, you just take the function, y equals x cubed. You interchange x and y, just interchange x and y, and then solve for y. So we're going to take x, put it here, y there, interchange, and then we solve for y. Just subtract 5, take the cubed root, and you get the inverse function is the cubed root of x minus 5. Okay, so that's how you find the inverse of a function. Alright, number 20, we want to find c function, which is here, evaluated at n of t, which is over here. So we're going to take n of t and put it into the c function. So we're essentially going to take this, plug it in for n. So here we have it, and we plug this guy in here for n when we get here. And then we just distribute. So 800,000 t minus 40,000 t squared. And then we simplify and we get a function that involves t only. Next question. Okay, so let's go here. Now here, just to remind you, you want to transform the bases. So this is base 3. How can we write 27? Well, it's 3 cubed. Now once the bases are the same, we just set the exponents equal to each other. So you get a basic equation, x equals minus 4. Here we want to write as a single log, so we can take 4 and put it on the exponent here. And then since the bases are both 2, the plus means multiply. So that's what I did here. And then the sum here means that we're just going to multiply this guy times whatever this guy is. Okay? So be sure you know how to expand logarithms. Now change of base is just, well, the log of 121 divided by log of 7. So that change of base formula is fairly straightforward. Make sure you know change of base. Okay, so here we'll solve. So we'll take and divide by 2. 7 over 2 equals 8. And now we'll take the natural log of both sides. So the natural log 7 over 2. And the natural log of e to the x was initially up here. I pulled it out front. Natural log of e is 1. So we just end up with x equals natural log of 7 over 2. So this one is a straightforward example here. Now here, half-life means the amount of time that it takes the original amount, 50 grams, to go to half of that amount, which would be 25. How much will be present in 320 years? So the idea here is that we have 50 grams originally, and then after 1690 years, we have half of that. So half, this red part, has gone away, and we're left with half. So the model that you want to know is given here. This is exponential growth and decay model. We're told that the amount after 1690 years is equal to the original amount times e to the k. T would be 1690 because that's... Now once we set this equation up, we just solve for k. So you can see the algebra here. We solve for k. K is equal here. we rewrite our model using K. We want to know how much is left after 320 years, so we just plug it in and we get the answer here. Okay, so be sure you work through one or two of these questions from the review in my math lab. All right, augmented matrix. This is real simple, just coefficients here. So 1 minus 2 minus 4 minus 4 minus 5, 1 minus 4 minus 1, 5 minus 3, 0, 2, and then 6, 6, 1, 0. So that's all there is to do that. Okay, here we want to solve. So we want to get 0 on the right and all the rest on the left. So that's what I did here. I1, I2 subtract over, which is minus. I3 is equal to 0. And then 6I1, we don't have an I2, we have a minus I3, and then subtract the 24 over. So we want to get, it said 0, but we actually want to get all the numbers on the right hand side. And then, so here we get 24 and 12 is 36, so subtract that over, and we got minus 6I1, 6I2, and then 0 for I3. Now, we enter this into the calculator, and we use our REF, and we get our solutions. Okay, so that's how we solve a question like that. Now, you want to know how to expand a determinant. So here I'm going to expand off of row 1. You can choose any row or column. So I'm going to say, now remember your sign rules here. Your sign rules are plus, minus, plus, minus, plus, minus, plus, minus, plus. So any way you rotate, okay, so this is going to be a plus sign here. So I got X, and then what you do is you delete this column in this row, and you end up with this determinant. So that's here. Now you move here. Since it's minus, it'll be a minus. You delete here and delete here. You got 2, 1, 1, 1, which is the determinant. And then the last one will be positive. Delete here, 2, 5, minus 3. So this is your 4 by 4 once you delete the rows and columns associated with this element. And from that point, you just find the determinant, so, and then you simplify. So determinant, remember, is 5 and then minus whatever this product is. Okay, so Kramer's rule, you want to do the determinant here, which for the correct expansion for z is just to take whatever z is, so 1, 4, minus 2, and replace that with the solutions. The x's and y's will stay the same. So this is the expansion for z, and then it's divided by the determinant, which is just 1 minus 1, 1, 2 minus 3, 4, 5, 1 minus 2. So that's going to be here. If it's for x here, then whatever the x's are here, you'll just replace with these guys. Okay, so it'd be minus 4, minus 15, 12, and then y and z will stay the same. So minus 1, minus 3, 1, 1, 4, minus 2. All right, so make sure you review Kramer's rule. And then the nonlinear system, well, since we've already got y solved for x, we just take y and plug it in here. So we get 2x plus 4 squared equals 16. That's what I did here. And then you expand this out, and you factor and set equal to 0. So we get x equals 0 and x equals minus 4/3. And then I plug that back in and I find out y. So y is 4 and 4/3. And you only want the y, so it's going to be this one and this one. I think she only wanted to only state the y values. Okay. So the last couple here, just write out the first couple of terms. So 2 2/3, 1 minus 1, and then 2 2/3, 2 minus 1. So these are the terms here, and we get 4/3 and 2, and so the common ratio is 4/6, which means it diverges. The sum is equal to the first term, which is 2, right? The first term of the sequence, divided by 1 minus the common ratio. The common ratio is here, and we get the sum is 6. And then the last formula here, the last problem, we just want to find the fifth term. So this is the formula for the nth term. N is 9, A is 3x to the fourth, and B is minus 2. So we just plug it in. So we get N, fifth term, is 5 minus 1, A to this power, and B to this power. Simplify, and we get this right here. Okay, I hope this helps, and you guys remember to study hard and do the My Math Lab practice as well online.